Okay, this is a little bit of theory, but it's very important theory, and I won't get another time to talk about this. So let's spend a minute on this. I mean, it's not even theory, it's really concepts. And I want to highlight to you that these concepts we learn through many, many years of programming. So I'm trying to speed up your learning curve by sharing these ideas with you. These ideas are usually not available in typical courses and typical books, because some people say, oh, it's a little bit conceptual, people don't need to know it. But I think you need to know it. So let's take a minute to think about it. So the first idea is to break a problem down into smaller pieces. Now, before we saw the idea of smaller pieces in the last section, where we had steps into which we broke a problem. Now we're going to see a bigger chunk. It's not individual steps, but a whole function, right? And so this idea is already with industrial engineering, we had learned this idea of making things into components. What are the important things about components is, you can solve big problems, difficult problems using components. Okay, so the one question that I've highlighted in red here is, when you start working on a problem, if I give you a problem to solve, how does your mind work? Are the steps the first things you go to? Are the functions the first thing you do? Functions or the components? Now, the advanced programmer will be able to think in functions, and you will get a little bit of chance to play with this. But as we write more and more programs in this course, it's a really interesting question. So there are two ways to do this. Today, I will give you a demo of what is called bottom-up. So in a bottom-up way, you just write all the steps, and then you rearrange the steps to create functions. There's also a way to go top-down. Top-down means that you think of the problem, and I say, oh, this problem, I think I need 3 functions. Okay, so abstract and advanced programmers will be able to see the components and functions right away. The new programmer may or may not. So I want you to reflect about this. Okay, every time you solve a slightly more advanced problem, sit back and say, what components will I need to solve this problem? Okay, and if you can think about that, then that would be wonderful. Okay, so monitor this, and we'll discuss this next time. The next thing is, we can all, there's inputs and there's outputs, right, for each function. But the output of one function can be put to as an input to another function. So the functions interact with each other, right? And the interaction is not dependent on what's inside the function. It's only dependent on the inputs and the outputs, right? So the interaction of components is through their interfaces. And by interface here, I mean how many parameters are there in the inputs and what's the return values. That dictates the interaction between the functions. Although as programmers, we have to understand what the function actually does, but to connect things together, we only need to understand the interfaces. So this is really important, and it's the next point. It's called encapsulation. Usually people talk about this only in very advanced, a slightly more advanced context. But once you write a function and you define its inputs and outputs, you really don't have to worry what's happening inside the function when you call the function, right? So that's really nice, because when you have a large number of functions and each of them is complicated, then you don't have to think about all of the details. You can just think about, it's like Lego blocks, right? You just have to connect them together and everything starts working. So that's very, very beautiful and magical when we get it all working well together. And so later we will write some programs to do this. This, I have to stress to you, especially for those who are new to programming, will take a little time. But I will keep encouraging you to do this, okay? Think about functions, because otherwise our code will become too big and hard to reason about and manage, which is my next point. Every time you write a small function, you can just test the function in isolation, right? You don't have to think about the whole problem you're trying to solve. For example, we wrote this function called double. We can just test, does it actually double my input? And after you've doubled the input correctly and written that function correctly, you can always use it in many contexts, and you're sure that it's going to do the right thing. So testing and finding problems, debugging will be easy. Okay, so take your time with these concepts. Think about this in your practice time. And of course, we can have discussions about this.